Good for everybody.
Yep.
So we're going to be talking about creativity in art and science, and obviously it's not something that I ever normally talk about. We scientists do experiments to figure out how the world works, how, in my case, how the brain works, but how different parts of the body work. So I thought I would give a very brief example of the sort of thinking that one goes through in doing an experiment. And sometimes it's not the scientists who do the experiment. Sometimes it's actually nature itself that does the experiment. And sometimes these experiments can be a little bit cruel. And that is the case with a gentleman I was introduced to now about 5-6 years ago or so. And I actually flew out to San Francisco to meet him because he was meeting with a group of neurologists there who were trying to persuade him to give money to them to consider supporting research in neurodegeneration. So what he was suffering from was a condition where in mid-age he starts losing the ability to talk and to walk. He found this, he was playing a game of frisbee, fell over, didn't understand why he'd fallen over. And it turns out that he has a mutation. He has a mutation, as you all know, we have about 30,000 genes that make up everything, every cell in our body to make it work. And he has a mutation in one particular protein. And this protein can be thought of as a string of letters, if you like. The DNA encodes the gene, and then the gene is translated into a string of amino acids. And you can think of this as a sentence. So this is his sentence on the top, what I call the good brain protein. And if you look through this, what you see on the top is what most of us have. But he has a spelling mistake in his protein. And you can see that the little G that's there, it becomes an R. This was really strange to us when we discovered this, because we really thought we knew how this protein works. It's well known that it's required for the way certain neurons in the brain generate electrical impulses, and they do that in the part of the brain at the back that's required for movement, the cerebellum. We thought we knew everything about it because everything the protein really does is in this top part of the protein. This part where this spelling mistake occurs shouldn't really have done anything. It's you can actually cut off that part of the protein and the protein still works, doing what we normally thought it does perfectly well. So the mystery is, why is this spelling mistake, this G to an R, causing all of this problem? In fact, we weren't even sure it was causing the problem, but there were good reasons to think it was. So you can puzzle about it, or you can go reading some more. And if you go reading, and of course you're not reading this in books, but you're looking at it in other genes and such like, you can find that some other places have this word. If you see this word where this spelling mistake is, it has lots of P's, then some H's, and then some more P's. And if you look in other species, in other cells, the first place you see this, H is in a strange place. It's in blood fluke, a parasite that has nothing to do with the brain, and it's something you don't want. But it's a very similar sequence. And looking through biology where you see something very similar, never identical, it turns out this sequence is always closely related to where cells have to take on a particular shape. It forms the shape of cells, not something that this protein was ever known to do. Well, how do you explore that? Well, then you sort of make a picture of the cell. And this is equivalent to making a physical painting of the cells. You can look at the cells, you make cells, and first of all, you start off with the most boring cell you can think of, which turns out to be a cell from the ovary of a Chinese hamster, and that's what you're seeing on the left. But then you put in the good protein and the bad protein. And at first you might see absolutely nothing, but if you paint it with the right reagents, so these of course not real physical paints, but these are molecules that illuminate different parts of the cell, you can start seeing that when you put the good protein in, the cell changes shape. But when you put the mutant protein, it doesn't do that. It looks very different. So you can see most of the colors in the middle are together, whereas most of the colors in the boring cell and the boring cell that's had this mutant protein added to it, they look very different pattern of staining. So this comes up an awful lot in science, where you just look at something and see, is it different? And you know, in the lab, many times I've had discussions with someone saying, "Does that look different to you?" No, I don't see it. Yeah, look. And eventually, this was very easy to persuade people. This was such an obvious difference. It's this thing going from the flukes to then deciding we should look at the shape that's actually now totally illuminated what this cell does, what this protein does. It does something totally different. In addition to what we knew it did, it has a completely different function in the brain. But more importantly, we can actually now fix this problem to some extent, knowing what it does. This patient is now on some drugs that are fixing this, and whether it will be a total fix or whether we'll need to do genetic manipulations, we don't know. But in summary, some rules of thumb for how you go around discovering things is that, first of all, you look at things extremely carefully, to look at the minutest differences and see if they're consistent. And then you make a picture. And what I've shown you is a physical picture where you actually look at a cell and you make a picture, you paint the cell with different reagents. But this can be a picture of what's going on in your head. It can be a diagram, it can be a scheme, but some sort of visual thing that explains to you in your head about what you think is happening. The next thing you have to do is that you have to be totally willing to go in a totally different direction from anything that you know about. So I knew nothing about movement. I knew nothing about blood flukes. There are many cases where you suddenly start to have to studying something that you never knew anything about. And on occasions, you actually totally change the whole direction of what your research group is doing. It can be considered a little bit scary because you need to generate salary for all the people who are working on this, and that requires persuading people to give you money to go in this totally new direction. But it's always worked out. If you're careful enough, you can really make some good discoveries by going almost in any direction you want. And finally, and most importantly, you have to have fun. You have to really enjoy doing this, because there's so much grunt work in doing all this. I have to say, I never enjoyed working in a lab, just pipetting, moving one reagent to another. It's not really a fun thing to do. But when you're thinking about what it means, that's where the fun comes in. And when you sort of make a diagram or a picture, and suddenly you realize something about how something works that you never knew before. That's what makes it all worthwhile. So that's my views on creativity in science and all the things it goes through. And well, let's move on to Corina. I will stop sharing.
Thank you, Len. It was very interesting to see the connections between science and art, and I'm going to share my screen now. Well, what's going on?
Corina, come a little bit closer to the microphone, please.
Okay, hold on. Let me, I don't know where I lost it. I had it on before we went on. There it is. Can you all see it now?
Yes.
Yeah.
So I'm going to talk a little bit about creativity during difficult moments, but it's general with everything with creativity in art and in any fields that I have tried. Constraints are always very good for creativity, because when you work with difficulties your brain starts to make connections, and which is what the concept of creativity is the ability to make connections. I came across this graph about thinking outside the box. They said that the scientist methods say that there's 4 parts to the creative process. One is the problem framing, like have a vision. Some people that says that the framing of the problem takes more time than actually coming with a solution to that problem. The other one is the integrative complexity, with connect the unexpected. So, like when you see people like Leonardo da Vinci and Michelangelo, all the things that they discovered was because they were curious and they were looking for things everywhere and trying everything to see what it would do. Trying feathers, trying pigments, trying looking at shape, looking at form, and that's how they started making all these connections. Then you have divergent thinking, which is the volume and speed that you use to produce your results. And I don't know if you know, well, everybody knows about Apollo 13, and I don't know if you watched the movie, but there's a part of the movie where the astronauts are about to die because CO2 is coming into the culprit, and they have to find a solution. So they say, well, try to figure out how they can turn a square in and fit it into a cylinder. And the way they solved the problem was getting all these very smart people from different fields and dropping all the things that the astronauts would have in space on a table, and by them working together using this divergent thinking, they came up with a solution, and we know the happy ending at the end. And the 4 is the extended effort, which is the grit and resilience. Because with creativity, it comes with a lot of failure and attempts, and you keep trying and you keep trying because you believe, you have a vision, right? That's number 1, you have a vision and you want to get there, and you keep working towards that vision at the end, and that keeps you going. And it actually, the working together with connecting the dots and all of this brings a sense of happiness and fun in the process. So during the quarantine, when we first started, I'm also a teacher, so I was teaching. I had to start learning how to work on Zoom and do all these new things, new technologies that I was not aware with. And at the same time, I'm preparing I'm getting my master's degree, hopefully this January, and I had to produce work for that master program, and I didn't know what to do because it was very hard. I was in my home, didn't have any access to the studio. So we came up with this quote by Theodore Roosevelt, to do what you can with what you have where you are. And that was a quote that I kept telling my students, that doesn't matter what they have, let's produce art with whatever you have where you are. And I was trying to mimic that in my own work. And my own work had to do with using the passed down handicraft techniques passed down by generations through the women in my family to tell a story of migration and community. And so I started to teach myself how to crochet, and I started crocheting materials that are not the common materials, but using whatever I had at hand at home as a way to index my time in isolation. The whole series is in Instagram. This is my Instagram if you want to take a look at it, and also my website, justcorina.com. And I started responding to things that were happening, right? So the shortage of toilet paper, the president saying to inject disinfectant to people, a way of a homage to the people that were the essential workers that were actually, going out, risking their life to bring us food at home. So this I made with the bags from the first groceries I received, and on a box also from groceries. And then the series kept growing, and it's now 60, and keeps growing. And actually this one here is now in the collection of the New Haven Museum. So embrace the constraints. Fill yourself with wonder. Be curious about the world around you and make connections. That's creativity, the key to innovation, imagination, and genius.
Great, thanks. I think that really sets the stage. Len, would you like to reflect on what Corina was talking about and this sense of circumstance and kind of how things present them to you, to yourself?
Yes, I mean, I can see so many parallels between what I was thinking and what she said, and it was very obvious in her talk. Yes. So first of all, circumstance. Yes. So things happen, like with people getting mutations or where you are or who you speak to. So many scientific discoveries have been made, at least in my lab, just by a chance remark of someone saying something. Oh, really? And then just going off in a different direction. The other thing that struck me, which we haven't really talked about before, but Corina brought up a little bit, was all of these people thinking together about something. So when you actually go into a new field in science or in art, talking to other people makes such a difference, or just reading what they've done. You forget about everything that you do, and then you suddenly have this new world opening to you, and then you try to bring the two together. But that's how you expand things, and that's obvious in Corina's talk, and it's clearly the case in science too.
Corina, what are your thoughts on that?
The same. I didn't go deeper into my process when I was talking, but it was the same. At the beginning, the first month, I was just worried about all of the people in my family, right? And all these branches, because you feel like a trunk and you have all these branches, and you're worried about their health and making sure that they're all taken care of and being safe. But at the same time, I needed to keep creating, because I believe that creativity helps my students deal with depression and isolation, right? So I started following these prompts from the Brooklyn Library. They have a sketchbook prompts, and I started following and posting them on the students' social media so that they would see that, you know, to stay creative, trying to encourage them, and at the same time trying to encourage my own self to keep doing something. And I started also following another friend of mine who was doing art prompts. And it wasn't until she said one day, face masks, let's make face masks, that I'm like, that's what I'm going to be doing. So it took somebody else to prompt something that triggered this whole thing in my head. And then I'm now down to 60 masks. So it's been like overwhelming.
So something about those chance remarks, I've realized so many of my collaborations have been because Sheila, my wife, met someone, for example, when we were at Caltech, who had a husband, and they were friends, and they came over for dinner. And then suddenly I started talking to the husband, and we realized we could really do something new together. And it's such a chance thing that Sheila actually ended up meeting someone. It's not something you could ever plan for, and yet it led to some real fun discoveries. So.
Well, that's fascinating, the role of chance and serendipity.
Yeah.
But it doesn't always happen, does it? I mean, what do you do when a problem is there festering on your desktop and you don't know what to do, and someone doesn't walk through the door and offer you a solution? I mean, how do you kind of butt up against that, and how do you approach a problem that at first seems insoluble?
So the answer is actually you have lots of problems, and some of them you solve and some of them you never solve, and some of them you think about for years and years and it never happens. So if you only think about one thing, you're going to fail. You've got to be open to all these serendipity aspects, and some of them will work out, but it's true, a high proportion of them fail. So yeah, you've got to have many irons in the fire. Not too many. You can't dilute what you're doing, but at least two.
I would add, don't be afraid to take risks. Just keep going.
That's absolutely critical. You know, when you think about it, you know, especially in science, where you're going to put someone's, it's not necessarily you if you have tenure, but before you get tenure, your whole existence is going to depend on what you do. And if you start doing something totally new, that could be a real problem. And it's certainly a problem for the students and the postdocs if you ask them to do something new that you don't know much about. And usually it works out. If the people have all those things we talked about, if they have the enthusiasm and spirit, they're going to make something of it. It's very much personality dependent.
Well, you guys make it sound easy. I know that those of us who have struggled either with art or science are, it's kind of discouraging. But I mean, tell us about the interaction between inspiration and perspiration.
Perspiration, I'd say most of the perspiration in science comes from getting the support to do the stuff, like writing the grants, trying to persuade people this is good, getting your papers accepted, moaning about the fact that someone doesn't believe you do it, and so you've got to do it again in a different way. That can be very perspiration inducing. But and especially in science, you have to repeat things so many times to know that they're true. So there is clearly a lot of perspiration in the science. Corina, what do you think?
Same thing. The amount of rejections we get are like we could cover a whole wall, right? of letters of rejections of our work. So until we finally make it, right? And we might make it one day, and then the next day we're all the way down to the bottom of the road. So we have to kind of start all over again. So every artwork that we create brings all of those set of challenges to see if we can make it or not. So it's the same. It's a lot of perspiration, but we enjoy it. So that's the beauty of it, right? At the end, we're happy.
You must enjoy it, otherwise it will devastate you. You'll just give up. And I know many people who just can't do it, and they've left science and they've have happy lives doing something totally different, like making a lot of money. So yeah.
Resiliency is important. You have to be resilient.
Yeah.
So we have a question from the audience. How do people who are not scientists or artists overcome the sense that they can't do things they haven't tried before or don't feel equal to even trying? Where does the well of creativity get dug if a person is willing but clueless?
I would say if you're willing, that's the most important thing to start off. That's what you need. And then you find people who are going to help you. If in any sort of beginning, find a teacher, find a mentor, something, talk to people who might be able to help you. But if you're willing to do it, that's where you start.
Yeah, the same. Yeah, I agree. Or now there's so many YouTube videos, but you have to be careful with the YouTube videos because sometimes people give you the wrong information. So you have to kind of like skim through them and try. Just don't be if you're not afraid and you're willing, just try and see where it takes you, and find people who can guide you.
And I think part of the answer to that is where Corina and Len both started, and that is in the framing of the problem, that you have to look at it with a certain skill set and a sense of adventure to say, okay, is there something that I can contribute to here? And what is curious, what's unexplained, or what's fun about this situation that I could possibly go into, and who can help me? Are there any other questions from the floor? So
there was somebody with the hand raised. I don't know who it was. I saw the.
Was there somebody with their hand raised? No. Can you describe for us maybe a situation that was perhaps not so easy, that presented serious difficulty, and maybe you came back to it after years, or it was never solved, and why it was never solved?
Wow. And the problem there is you try to repress those sorts of things. Otherwise, if you so they're probably back there somewhere. But yeah, I mean, I can think of technical things that have puzzled me. I mean, basically, how does a brain cell ever work? It just doesn't make any sense. There's so many thousands of things that have to be right, and you can make computer models, which I do a lot, and you put these numbers in a computer models to make a sort of simulation of it, and you find that if you just tweak one number slightly wrong, the whole thing falls apart. Something in nature allows all these different thousands of things to work together so that every neuron in your brain knows exactly how and when to fire and what it needs to do. That's a problem that has puzzled me as to how that actually happens, how all of those different things talk to each other. It could be a very simple answer, something about the way different genes are regulated and so forth, but actually it's quite a deep problem, and I don't know how to solve it. I'd love to know if anyone has any ideas in the audience. That would be great. But
so it sounds like there's just an intrinsic complexity to the situation, and you've been looking for a handhold, but for whatever reason, it hasn't kind of appeared out of the mist.
Yeah, I mean, some people could call it homeostasis. Obviously, things have to go back to a certain thing, but it doesn't apply to the brain, because the brain is changing every single day. You are different tomorrow than you are, or you are different after this talk than you were before this talk, because things have changed in your brain. So it's not homeostasis, it's something else, and yet the brain keeps on working in most people, not in all people. That's the problem.
I have a question for the professor. I understand that the spelling mistake, I mean, I understand it's a problem, but if you have from your mother and your father 2 sets of every gene, why wouldn't the other side take over?
Well, that's the concept of dominant and recessive genes. So we have in many cases, just one copy is the problem. So that spelling mistake, it could just not work. And if it doesn't work, that protein, you can forget about it, and it's recessive. The other protein that comes from the father or the mother, the other one will do all its things for you. But often what happens with the spelling mistake is that it's a gain of function. Instead of just not working, it actually works way too well, or it does something it's not supposed to do. And then the other one is never going to compensate, because this one is telling the cell to do something it's not supposed to do. And it's not its normal job to tell the cell to do that, but the cell is responding to that spelling mistake. And the way to deal with that actually is, which is what I'm involved in a lot now with a couple of groups, is you want to delete the bad copy of the gene. So there's something called antisense oligonucleotides, where you can inject DNA or RNA actually into the body that will meet up with the bad spelling mistake and try to destroy that gene, or to destroy the expression of that gene.
So will the other side take over then?
The other side in most cases will continue to work, and that would and that's a partial cure. Yeah. So there are many cases where not having, if you simply get rid of the gene, it's worse than having the spelling mistake. If you get rid of the gene, the cell, the body can cope with that, even total loss of the gene. But having a mistake that is telling the body to do something it's not supposed to do, that's the problem.
I see. Thank you.
So Len, can you say a word about your patient? You started with him, and we don't know what happened.
So I still I Zoom with him. He clearly has deteriorated in terms of his ability to move and talk since then. But just recently, we have started on a drug that, from what we've learned, help. And I'm not a neurologist, so the neurologist who sees him every week tells me that he's improving, which is, of course, a great sign, but it's still not a cure. One of the things that we're considering is actually doing what I just talked about to knock out the bad copy of his gene, because he just has one copy, and if we could just get rid of that. Usually these techniques of getting rid of one copy of the gene is being applied to little kids. This person is now in their 60s, so that's a little more difficult to try and do that.
Mm-hmm. So Corina, how do you see your mask project evolving? What's the next step?
I don't know yet. There are several ideas circling in my head, and also the way of displaying it, right? Because it started as a work done in isolation and meant to live in the new world of the web, right? And find connections through this web, the internet, right? It came from the connections to my ancestors and how they passed down techniques and how the females in the families were getting together and finding connections that way. And now it has moved on to bring all technology of the handicraft into the new technology of the web and the internet and finding connections that way. So that's where it is right now. And I have to, like I was telling you, right? You do a body of work, all of a sudden is successful, and then what next? You have to start all over again.
Okay, are there any more questions from the audience? You can, if you have a question, you can go ahead and unmute yourself.
There's Kate Galan.
Hi, yeah, I have a question. Thank you. I'm really enjoying this conversation. I just wonder if you have ever noticed that when you go to bed and then you wake up in the morning, you have the answer, or you see a picture now, mind rest, I guess, and then having the new idea the next morning. Thank you.
Sometimes in the middle of the night. Sometimes in the middle of the night, and then sometimes I have a sketchbook next to my nightstand. So sometimes I don't want to wake up, because if I wake up, I might lose it. So I just stay with my eyes closed and draw my ideas or take some notes. And then the next day I'm trying to figure out what was that I wrote in there.
So,
but, yeah.
Yeah. Why does that happen, Corina? What's the process in your consciousness that allows that creativity to bubble up when you know other things aren't going on? How do you understand that? Well,
in a teachers conference I had a few years ago, there was this science teacher who gave an explanation of why it was important to sleep, and especially for her was the point of view of the kids, how they needed their sleep. And the reason why you need your sleep is because when you go to class, where you're paying attention to something, your brain only captures part of it. It doesn't capture the full picture. And it is when you go to sleep that your brain starts making the connections and all of a sudden has the whole story. So I think that's what it is. When you go to bed, all of a sudden your brain starts making all these connections, deleting what is not useful, and bringing up front what is useful, and then all of a sudden you have the answer that you were looking for.
Yeah, I think there's also something else that goes on. If you're actually looking for the answer, you're thinking about all the well-known things that you already know, and you keep going down the same avenue again and again and again. And for me, it doesn't happen so much in the middle of the night. I'd much rather sleep then. But I realized one thing about the pandemic that I really now miss, and I never thought I was going to say this, but getting on planes and getting on trains. Because when I'm on a plane or on a train, I just let my mind wander, and I'm looking out the window, and I can go all the way to Washington just looking out the window. But that's when just things start to come together that if I'm thinking consciously about that, they wouldn't do. So it's probably the same thing as at night. Yeah.
So that's amazing that problems get solved by a combination of your own inner processes, forgetting what you think you know, and also forces from the outside, be it the pandemic or collaborators or friends of your wife, come in and offer you solutions if you're open to them.
Yeah.
Great. Any other questions from our
Can I just make a comment?
We have one.
Sorry, go ahead. But
go ahead. I'll read it. You both talked a bit about collaboration within your respective fields. Do you have any examples of collaboration with people totally outside of your disciplines or fields. Len, I think you described that.
So only in the sense that there are people who have these mutations, are very interested in particular diseases, and I've got to talk to a lot of those people. They are either patients or they know people, and that can drive your research. The things they suggest, they're not scientists, but the fact that they're interested in certain things and they persuade you to go in certain directions, that I would say that's as much as a collaboration, because it's making you do something that you wouldn't have done before.
Well, in my
Corina?
case, I work at a school, right? So I'm always collaborating with other teachers, and you know, and also in the art world, I'm collaborating with my friends in different ways.
So how do they help? How do they help you?
I'm sorry?
How do they help you? Is it offering solutions? Is it more releasing your inhibitions? How does that happen?
Maybe a combination. So it's sometimes I ask the question, sometimes I don't, but the answer just comes up, or my brain makes the connection. I don't know how that works, but like for example, this friend posted what prompt to make a mask, and that prompted in my head what I needed to do next, because it was something that was, you know, that was actual, that was happening, and I could still use the same techniques I've been using during my grad school program. So it comes from different sources, not only your own brain, but also the outside. Like walking around in nature. I love walking in nature and just seeing what's out there, and maybe grab things that people would not normally don't do, right? Because they just capture my eye. And then those little things, all of a sudden you started making things with it. And when you were talking about having work not unfinished, I have tons of work unfinished, and works that all of a sudden I bring them out again. I'm like, oh, I can use this for this work and to take the message that I want to tell. But at the moment when I made them, I had no idea what I made them, or, you know, what could I do with it after that? Or it's just unfinished because what I was doing wasn't really taking me where I wanted. And it maybe years later, I came with new eyes and I finished it. So it's a process. It's not a perfect line, right? It's not a straight line. Yeah.
So we have here perhaps the most difficult question of all. Is it possible to make a mask where your glasses don't steam up?
Well, they have all kinds of things that people are invented. There's like something rubbery that people put under the mask for that. I tend to put my glasses, I actually have a mask here. Put the mask and then put my glasses a little bit over. And that seems to work, especially when teaching. Another thing that I did, I would just get a tissue, like facial tissue, fold it and put it on the top of my nose and then put the mask right over it. And that seemed to help too. But the best for teaching was like just putting my glasses a little lower on top of my mask. And that made the trick for me.
Okay, well, I think everybody is now happy that they've attended the Branford Forum too. So thank you so much both for joining us today, and thank all our participants for tuning in. I hope it was useful. We wish everybody a wonderful holiday. Stay safe, stay alone, and we'll see you in January. Thank you very much, everyone.
Thank you for having us.
Thank you.